Hello, welcome to our lesson on application of linear models, where we'll look at things that exist in a linear relationship in the real world and determine what all the numbers surrounding that function actually mean. We'll look at four examples. In each case, we'll be given different information and we'll be asked to come up with the linear model. First example, in our first example, we're looking at someone's taxable income, which is represented by I, versus the federal tax that they actually pay, represented by T. And we went ahead and put those on a graph. And what I want you to recognize about the graph is that the units on the graph are 1, 2, 3, 4. We had to scale the graph to represent the data we were looking at. So on our graph, the t-axis, which would be our dependent axis, the paid, which depends on your income, is scaled so that every block is 500. And then the x-axis, which is now called the I-axis for tax income, is scaled from 2 to 24. So we should note that this is income in thousands of dollars to avoid writing all of those extra zeros. And when we plot the taxes paid versus the income, we can see that they follow a very straight pattern, nearly perfect. In fact, it is perfect. So we want to be able to write a model for this data so that we understand the relationship between the income that you earn and the taxes that you pay. Since we know it's linear, we're going to first determine the slope of the line, which is m. And from algebra, you remember that the formula for slope is y2 minus y1 over x2 minus x1. Each of these is a point in the table, so you can pick any 2 points. When we do that and subtract, we're going to have taxes over income, important to our interpretation. And I'm going to pick the points that go with $24,000 and $18,000. It does not matter which two you pick. $24,000 goes with $3,239 in income tax and $18,339. I would not expect you to do this calculation in your head or by hand. Feel free to go to Desmos or use your calculator. And when you do that and reduce your fraction, you're going to get 3 over 20. And it's fine to leave that as as the fraction, not as a decimal. And that tells us that for each $20 in income, you would end up paying $3 in tax. They're both positive, so as one increases, the other increases. See that positive relationship on the graph. So the t-intercept, remembering that we graphed t on the vertical axis, this is the same as saying what is the y-intercept. We just had a different letter that was more specific to our question. In order to calculate that, we're going to go back to our definition of a line, mx plus b, and recognize that we already know the slope, which is 3 over 20. And if our goal is to find b, we can substitute any point we wish for the x and y. So I'll substitute the point that goes with $15,000 income. And again, using Desmos, using your calculator, we would multiply. And then to solve for b, we would subtract $2,250 from each side, which would give us negative $361 for b. The practical meaning. Whenever you interpret the practical meaning, I find it helpful to put your y-intercept back in its ordered pair and think about what each part means. The x is I, income, and the negative 361 is T for taxes that you would pay. So this tells us if your income is 0, you pay no taxes. It's not a positive number. In fact, the government pays you. And we could think of that sort of social support systems that are out there for people who are unemployed. If income is zero, a negative tax means that money would be coming to you from the government. Now that we know those two things, we can write an equation in slope-intercept form. We are told to use those variables I and t. So we're going to start with t and use function notation to say that taxes are a function of income, and our slope was 3 over 20. We're going to multiply that by income and subtract 361, and that would tell us the tax that we owe. In our last question on this page, we're asked to determine what the federal tax owed by a college student would be if they earn $8,600. So we can label this very quickly. We know an I value. We're going to go to equation, and wherever we see I, we're going to substitute this income. And again, this is a use your calculator calculation. So you would just type this right-hand side into your calculator, and it would tell you if you earn $1,600, you would end up paying $929 in income tax. All right, in our second question, you'll notice there's no graph. Not a big deal. We have enough information to generate a table of values and understand why this would be. So you're purchasing a used car at CarMax, and when you purchase a car, new or used, it tends to lose value over time. So you find out that once you pay $20,025 for this car, that its depreciation, so its loss of value per year, is a constant of $1,385. So we're going to create a table for how much that car is worth, and for years, we're going to understand that this is simply the year of purchase or the day of purchase. No time has passed, so we'll assume that at that point the car is still worth $1,025. After 1 year has passed, you're going to lose that much value, $1,385. So now your car valued in the 18,000s, and again we would subtract to get the value every year thereafter. Because that loss of value is constant, it stays the same, anything with a constant rate of change is linear, and we're going down the same amount every year, so we know this is linear. As we're writing our first thing we would want to consider is what are the independent and dependent variables. So when I always think about dependent first, this is the value. It depends on time. And our dependent value is always the y variable, and our independent variable is always the x variable. Probably know that from science class. Moving on is our same table of values. I just replicated those so we could continue to look at those. And we're going to find that average rate of change, which is called the slope. Some of you may know the answer to this question already, but it's worth showing that we can find it from any 2 points. So I chose years 4 and 2, and their associated values would be subtracted on the top. And that would give us negative 1385 over 1. So always leave your slope as a fraction. Put it over 1 if that's helpful, because it is helpful to interpret it. On the top, we subtracted amounts of money, and in the denominator, we subtracted years. And because our slope is negative, that's telling us a loss. Our car decreases $1,385 in value each. When it comes to our y-intercept, we actually already know what that is. It's always 0 for x and then a number. And for us, that is 0, $20,025. So in this case, the y-intercept is $20,025, and that is the initial value of the car. So it's good to remember that when you find y-intercept, the value that you're talking about can often be discussed as the initial value when the other variable is 0. Now that we know the slope and the y-intercept, we can say the value of the car based on number of years is negative 1385 n for number of years plus our intercept of $1,025. Some people, because it's a loss of value, prefer to write the equation this way with the intercept first and the slope following. Either way is correct. In either case, our slope is negative 1,385. That was the equation that we wrote. I did it here so that we could answer our last question, which is about x-intercept and its practical meaning in this problem. If we're talking x-intercept, that means we're looking for an x value when y is 0. So we're going to make the left side of the equation O. And then we're going to solve for x or for n, however you wrote that. This is negative 20,020 now. Excuse me. Then we would divide both sides by negative $1,308. And that would tell us that x is 14.45. So in approximately 14 and a half years, the car has no value. All right, in that last question, we went ahead and made a table of values that showed us that our change was constant, but sometimes we can simply read information and find that out as well. In this case, we're taking out a personal loan for $2,500 and make a monthly payment of $55. We're going to assume this comes from our parents and they're not going to charge us interest as we pay this off. So the loan value will be determined by how many months have passed. Because our payment is the value of the loan, our slope is actually negative 55, and we're paying that monthly. So as it passes by, we take $55 off the value of the loan, and the initial or the starting value of the loan was $2,500, so that becomes our y-intercept. And we can identify this because this is initial, so that makes it b, and this is our slope as we read the problem, because it is the constant rate of change. So there was no need to make a table of values. We could simply read and understand those two numbers. Our negative 55, and if I have to interpret it, I'm going to put it over 1 and remind myself that 55 is in dollars and 1 is in months. So it is telling us that the amount owed decreases $55 every month. If we're asked to interpret y-intercept, I always am going to put that as an ordered pair with 0 and the intercept, and remind myself that 0 is m, or months, and y value, our dependent value, is money. And this tells us that $2,500 is the initial value loan. Once we've written that equation and understood what the slope and the intercept ask us, we can answer this question: how much are you going to owe after 1 year? But be very careful with your units, because our units here are months. So 1 year is 12 months. We would not be making very good progress if we just plug in. So we're going to plug in 12 to indicate that we've made 12 monthly payments. And again, onto your calculator, multiply and simplify, and this will tell us that after 12 months, we now owe $1,840. When we pay off the loan, its value is 0. So the loan would be worth 0. So this is asking us for the exit, where we find a number for months when the loan value is 0. So we go back to our equation, we make the left-hand side 0, and we solve for m. Subtract 2,500, divide by -55, and we'll pay off the loan in 45.5 months. Probably won't make a half-month payment, so we'd finish paying off our parents in 46 months. The last kind of problem we'll approach is one where we only have half, and we're asked to write the linear equation that represents this graph. So we do want to write this as y equals mx plus b, follow that format, but we're going to be using age, w, and s for sales, those variables. So sales are x and w are our y values. And the first is look and see if I can find the y-intercept, which is right here. Easy to find. Our b value is 250. Sorry, that's difficult to read. 250. And again, paying close attention to that scale, it's not because I went up 5 boxes. We had to look and see that each box was worth $50. That's going to be important as we calculate the slope. If we can see it, we can calculate our slope simply by making that triangle between 2 good points. So I can see 2 good points here, and I'm going to count the rise and count the run, but I'm going to pay really close attention to the units on each axis. So the rise here is 1 box, but what that really is $50. And the run here is 2 boxes, but that really just represents a sale of $1,000. So our slope is $50 in wages for every $1,000 that we sell. And we're using thousands of dollars as our unit, so we're just going to leave that as 1. So the wages, based on our sales, are $50 times our sales, that's our slope that we just found, over 1, plus our y-intercept, which is 250. So base salary, that would be before you sell anything. So if your sales are 0, how much are you? This is another way of asking for the y-intercept, which we've already found. That is 250. This next question should say, find the weekly if the salesperson makes $33,500 in sales. Want to plug in that huge number and multiply it by 50. That would give us an exorbitant salary. So we need to transform this into thousands of dollars before we plug it into our equation. So we're going to make this 33.5, which is how much we've sold in thousands. We're looking for the wage if we've sold $33,500 in merchandise. So we're going to plug that in for S. Those are our sales. And again, we're going to go to our calculator, Desmos, and we're going to plug that in, and it would tell us that we would earn $925 a week if we could sell that much merchandise. If our goals are less ambitious and we just want a wage of $830, that would be a number to plug in on the left because that's a Y value. It's on the vertical axis. We need to find the sales, so obviously that's going to be the variable we solve for. And again, with a calculator, you can subtract 250 from sides. We can divide both sides by 50. And it tells us our sales would be 11.6. Remembering those are in thousands of dollars, that tells us we would need to sell $11,600 worth of merchandise to earn that salary.